Welcome to Ask and Learn.
To figure out the radius of convergence here, we'll use the ratio test. So take limit as n goes to infinity of absolute value of an plus 1 over an, where an is this whole chunk here, including the x values. So this is limit as n goes to infinity of absolute value of x minus 1 to the n plus 1 over 2 times n plus 1 minus 1 times 2 to the n plus 1. So this is our an plus 1, except we've tossed out the minus 1 to the n. And then we're dividing that by an, which is the same thing as multiplying by the reciprocal. So now we're multiplying by 2n minus 1 times 2 to the n. And we're dividing by x minus 1 to the n. X minus 1 to the n plus 1 divided by x minus 1 to the n is just x minus 1. So this is limit as n goes to infinity of absolute value of x minus 1. And then we have 2n minus 1 over 2 times n plus 1 minus 1 times 2n over 2n plus 1. So we just rearrange things a little bit. This limit here is 1 because we have something linear on top with leading coefficient 2 and something linear on the bottom with leading coefficient 2. So as n goes to infinity, this goes to 1. Here we get a bunch of cancellations to happen, and we're just going to be left with one copy of 2 down at the bottom. So this turns out to be absolute value of x minus 1 over 2. And we want for this to be less than 1. So x minus 1 over 2 is less than 1. If we multiply both sides by 2, we get absolute value of x minus 1 is less than 2, which means that x minus 1 is trapped between minus 2 and positive 2. So if we have minus 2 is less than x minus 1 and we add 1 to both sides, then we get minus 1 is less than x. And if we have x minus 1 is less than 2 and we add 1 to both sides, then we get x is less than 3. So x converges between minus 1 and 3, and at this point we're not yet sure whether or not we get convergence at minus 1 and whether or not we get convergence at 3. But we do know that the length of our interval of convergence is 3 minus 1, this value minus this value. So the radius of convergence is the length of the interval of convergence divided by 2. So we get 4 divided by 2, so 2. So 2 is our radius of convergence here. The interval of convergence, we need to figure out whether or not to include minus 1 and whether or not to include 3. So if x is minus 1, then we have minus 2 to the n here. So minus 2 to the n is minus 1 to the n times 2 to the n. So minus 1 to the n times minus 1 to the n will cancel. 2 to the n divided by 2 to the n will cancel. So if x is minus 1, we get a bunch of cancellations to happen, and then we just have sum 1 over 2n minus 1. And this is going to diverge because we can compare that to just 1 over 2n. This denominator is smaller than this denominator. So that means that this value has to be bigger than this value. This is 1/2 of the harmonic series. Harmonic series we know blows up. So this is divergence here. So we don't want to include x equals minus 1. For x equals to 3, if we plug in x equals 3 here, then we have 2 to the n. So we have 2 to the n canceling out with the 2 to the n down there. So then we would have minus 1 to the n over 2n minus 1. And this is going to converge by the alternating sign test. Okay, so 3 works, minus 1 does not work. So we do not include minus 1, but we do include 3.